Alright, hi you guys and welcome. Today we are going to be talking about working on conditional statements, okay? Alright, and conditional statements are basically just some of this stuff, okay? So we've got an if hypothesis, then a conclusion. It's the infamous old argument that you used to have with your parents of, if you do the dishes, then you can go out with your friends on the weekend. That type of thing. So we're going to dissect that logic and work through it, okay? Alright, so first off, we're going to check off hypothesis. Hypothesis is just the first question proposed. Now, hypothesis does not include the if part. So if you're ever looking for a hypothesis, don't say if I do the dishes. It should just be you do the dishes. That would be the hypothesis. Okay? The conclusion is what logically comes after. Okay, so just looking at that is just working it out, just seeing how it works out there. Okay, all right, now this whole thing all together, this becomes the conditional. Okay, so the conditional is if the hypothesis happens, then the conclusion should logically happen right after it. Okay, what we're going to do is we'll talk about these three bad boys a little bit later, and including equivalent statements. Okay, and then we'll also talk about negation and truth values. Now, what if you're just given a regular plain old statement? How could we transform this into an actual conditional and just work with it? Okay, so you start with your first one. Piano players are musicians. Okay, so basically what we can do is we can transform that into a conditional statement by saying, okay, if you are a piano player, okay, that would be your hypothesis, okay, of working on it. And obviously you'd have to work out the kinks of typing in spaces and stuff. Okay, so your hypothesis would be if you're a piano player, then you are a musician. Okay, and that would be your conclusion right there that you could base upon this logic, okay? Now you could also say if someone is a piano player, then they are a musician. You could also say that. I like to put it more personal and make it more interpersonal like that, okay? All right, let's go take a look at all the statements. Okay, so here's all the statements. Oh, sorry, let me go back real fast. Okay, now, long story short, you guys, okay, if you take a look right here, a conditional statement becomes P, then Q. Okay, and it's this P, then arrow to Q part. So the P is actually the hypothesis, and the conclusion is the Q. Okay. All right, so now, in truth tables and just working with stuff in general like this, you can actually just basically break down all of math into just symbols. Okay, especially these conditional statements. Okay, so our conditional statement is if P, then Q. I like to use the famous one of I go to the movie theater, okay, and then Q will be I get some popcorn. Okay, so in this hand, it would say, if I go to the movie theater, then I will get some popcorn, is what this conditional would be, okay? Which appears like this. If I go to the movie theater, then I will get some popcorn. Now the converse is you just switch the conclusion with the hypothesis. So it'll look like something like this. If I get some popcorn, then I will go to the movie theater. Which looks like this. Now, we'll talk more about some fallacies of this type of logic, but for right now, let's just assume that that's just going to happen. All right, now, negation. Negation's going to look like a tilde. Okay, and negation just means not in math symbolism. Oops, clicked the wrong one. So it's just the tilde right there. Okay, so what this is essentially saying, now the inverse, okay, so the converse is just you reverse the hypothesis and the conclusion. Now the inverse is, it's going to be the same exact way as the conditional up here, except it's going to have two negations. Okay, so how does that read? If I don't go to the movie theater, then I won't get popcorn. Which would look something like this. If I don't go to the movie theater, then I won't get popcorn. Okay, now contrapositive, okay, is going to be you reverse the conditional and the hypothesis, and then you put negations in front of each. Okay? And so it's going to say, if I don't get any popcorn, then I will not have gone to the movie theater. You could say one-way version of saying it, which looks like this one. Okay? All right? Now, here's some really kind of cool things that we can do with this. We can actually make some things called truth tables. Okay? So what you do is you just put down true, false markings as you go. Okay, so true, true, false, false. You just put down all the possible combinations. So you could have a true, true, you could have true, false, you could have a false, true, and then a false, false. Okay, for P and Q. So that's just the combinations. So when we apply that logic to these types of situations, and we're going to say this is the conditional right now for this one, and you can make truth tables for each one, and I'll tell you some shortcuts to working with it. Okay, so basically the true statement is P, so the conditional is true, then this is true. Okay, now if the conditional, or I'm sorry, the hypothesis is true, but the conditional or the conclusion is false, then I just told a lie. I basically told you a lie. So, like for example, if you did clean your room and then I would let you go out on the weekend, if you did clean your room and I didn't let you go out, I would be lying. So that's basically that. Now here's the really cool thing. For these next two, okay, all right, some really cool stuff can actually happen. The truth table appears like this. If you didn't clean your room, I could tell you anything, and it could be totally true. And it's weird because this truth is actually true, and this one is also true. So whenever the hypothesis is false, no matter what happens with the outcome of the actual conditional is going to be true and true. All right, now I probably know that confused a lot of people. Okay, and unless you're literally going into logic and stuff, you probably won't need that as much. So let me tell you some truth equivalencies. Okay, amazingly enough, the counterpositive and the conditional are actually both equivalently true. In other words, their truth tables are going to look exactly the same. Okay, their statements are going to say different things, but they're going to say the same exact thing. All right, now, however, the converse and the inverse are also truthfully equivalent. They're logically equivalent. So if you made truth tables for these ones, they would actually make sense too. Okay, and here's what, for example, let's take a look at the converse truth table just to see what it would look like. Okay, so now remember, even though we've reversed the letters, it still follows the same logic. True, false, true, true. Okay, as we work through this. So, and remember, I switched these two, so it's going to look a little bit differently, okay? All right, now another thing is a biconditional. Now, biconditional is going to look like this. It's going to have a double arrow between the two. And it means, basically, if I were to translate into the translation of what we have, if I get some popcorn, or I will get popcorn if and only if I will have gone to the theater. Or I will go to the movie theater if and only if I can get popcorn. And I can tell you right now, I love to do that. So that's something I would honestly do all the time. Okay, so that would be my biconditional. Now that doesn't show up as much in this chapter, but it's nice to know that there is a biconditional out there. And it's actually got a really cool statement in between. You can actually use it as P, and then I double F Q, and that actually is equivalent to the double arrow part of it, okay? All right, well that's it for conditional statements. Good luck, and I'll talk to you later.